Okay, so now let's combine what we've done with a vertical circle with a horizontal one. It's really just a horizontal one, but there's something that is at an angle. So I have a ceiling, I have a rope connected to a mast, and it's going to swing. Maybe I hold the mast and I throw it, it's going to swing and go in a circle, right? So at one moment it's here, at another moment it's here, but it's going to go in either clockwise or counterclockwise, depending on are you looking at it from the top or bottom. Yeah, but it goes in a circle, right? So now my question is this. I measure just the angle, right? Let's say it's 30 degrees, okay? If I measure the angle over here, can I tell what is the speed it's going at? And can I predict what is the period it has to go at, okay? So what is the speed? Notice no vector sign, so just speed, not velocity, even though we still use v. What is the period of it? Okay, and we'll be careful not to use t for tension with any of these problems. Okay, yeah, and also what is the tension that the rope would go as well. So let's say I know the length over here, and I know so you're given the length, you're given the angle, so you can measure the angle, you can measure the length. What is the speed it is going at? What else do I need? Let's see. Yeah, and I need a mass, of course. Yes. And you are missing something. So with certain mass, let's say you have 2 kilograms, you have a length of 1 meter and 30 degrees. Okay, what would the speed be? All right, so I'm going to solve this generally, so you can plug in the numbers at the end because anyone can plug in numbers, but the main part is to know how to analyze this, right? So again, draw the free body diagram, identify what is the, so start with the free body diagram, identify your centripetal forces and equate to mv squared over r and solve for whatever you're looking for. All right. So what's the free body diagram over here? What's touching it? What's in contact? Well, that's the tension. All right. So we're going to call that tau over here. Yeah, we're going to solve for the tension as well. All right. So that is all the contact force there is, and then there is the weight. Okay. Okay. So now there is a diagonal force over here. So you immediately, it's begging you to resolve that. So you have now a tau x and tau y as your tension, like this. Okay. All right. So what can you say? Well, if it's going in a circle, this better not go up and down. So it's not accelerating up and down. Immediately, you can form an equation and say that, hey, I know that tau y must equals to w. And this is by first law, right? By Newton's first law, these two must equal. Otherwise, it's going to accelerate either up or down. And then I also know that in the horizontal direction, that is my centripetal force. Okay, so there's two ways to go about it, right? So one way is what I've shown you earlier. So you just identify the centripetal force is Tx or tau x, like this. So that's one way to go about looking at the horizontal. Okay, so this is the vertical axis, the horizontal one. You can go with that method, or you can say, go back to Newton's second law, right? Start with ma equals to F net. Now you say, I want the centripetal acceleration and centripetal forces. So centripetal acceleration, what direction is that? The direction is always towards the center of the circle, right? And I have a formula for that, is v squared over r. So that's the speed, and that's the radius of it. And what's the net force towards the center? Because this one, the direction, right? The direction is towards the center. So this one better be also towards the center. It better be the same direction, like that. So what's towards the center? Tau x. Okay. As you can see, we get the same result, the same next step, like that. Okay. Yeah. Then what is tau x? Well, we know how to resolve forces, right? So we need to find an angle. We have an angle over here. That's theta. So that means this is theta, right? Just with parallel angles. So we see that this is sandwiching tau x. So we see tau y is tau cosine theta, and tau x is tau sine theta. Right? If one is sandwiching it, that's the one with cosine. The other one opposite it is going to be sine. Okay, so now you can put this in here. Since it's the same, I'm just going to continue with one of the sides. So mv squared over r is tau x, so sine theta. All right, what is my aim? My aim is to find first, what is the tension around the rope, right? Well, there's something we can do here as well. We can also realize that this is mg, right? So the next step implies this is tau cosine, I believe, equals to mg. And that will tell me tau is mg over cosine theta. Do I know m? Yes, it's given. Do I know g? Yes, it's a constant. Do I know theta? Yes, it's given. Okay, so I will be able to find tau. Now, then I can find v. To find v, that looks like a good equation to use that has a v in here, right? So let me see, what do I have? I have m, I have theta, and I just found tau. So what I need is r. What's r? 1. No. R is the radius of the circle. So don't trivially just plug in the 1, but you understand r is the radius of the circle. So let me extend that line down to here. You can see I should figure out what the r is from the given variables over here, right? So let me draw that out loud over here. Larger over here, so this is theta. So what's the relationship, right? That's an opposite, right? So it's a hypotenuse times so r is L sine theta, right? Or you can do one more step to be sure, right? Sine theta is opposite over hypotenuse, so you can get that. So what do we have? We have mv squared over r is L sine theta. Tau we have figured out over here is mg over cosine theta, sine theta. Right, now we can solve for v, and we can find v squared is lg sine squared theta over cosine theta, right? And we can take the square root, and every time you take a square root, there's a plus and minus until you convince yourself that one of the solution is not relevant, and the -1 is not relevant because this is a speed. So you can just have that. And what is the period? Well, we can connect v with the period, right? So how much time it takes to go around for one circle, one revolution. And remember, v is the tangential speed, is the tangent speed around that it is moving at. It moves how much distance? It moves 2 pi r per period, right? The time taken to go 2 pi r is t, it's capital T, and the distance it has traveled in the whole cycle is 2 pi r. Okay, so now, do you know r? Yes, it's L theta, which both of them you have. So you have, so to find a period, you want 2 pi r over L. And as a general advice, as you can see, try to keep things in variables. Of course, in an exam, r is L sine theta, yeah. In an exam, you can do either way. You can plug in the numbers, but this will usually get you more marks, more points, more partial credits because it's traceable. Because if you plug in a number over here, every step you're just producing numbers. And where was I? Divide by, not L, divide by V. So if every step you're just plugging in numbers, then the grader or the TA will have a hard time to see where you made a mistake if you have. So if you make a mistake somewhere halfway, everything else will be invalidated because we cannot see what's going on. But if you do things with algebra, then we can see, oh, you made a mistake over here, that's fine, we'll deduct a point over there, but everything else seems fine. We'll still give all the remaining credits that way. Whereas in the other way, if you made a mistake somewhere, so the number is not correct, it will affect all the numbers, and we can't trace numbers, right? If you just put in so that would be much more harder for you to get partial credits. So over here, LG sine square theta over cosine theta. And I think if I have simplified it correctly, you should get 2 pi L cosine theta over G. Okay. You can double check that. You can plug in the rest is just plugging in because we know we're given L theta and G. Okay, so this is the conical pendulum it's like a pendulum, but it's going in a cone shape. So that's why it's called that name. So I think really that is the main concept of everything. We'll take one more video to look at a car going around a bank that's going around a banked curve, and that will just give you some more concrete applications for this. But yeah, all the physics is really summarized in these examples. Okay, so you can start to look at some of the textbook examples and look at some of the practice examples at the end of the chapter, and you'll see it's all sort of variations of this type of question.